Before to start implementing and creating some components, we need to understand the technologies that we are going to use and, of course, the architecture that we are going to implement along the course. So, what is Lumen exactly? Well, basically Lumen is a micro framework based on Laravel. Laravel is basically the best framework that exists for the PHP language and provides you a lot of capabilities. But that makes that a little slow because, well, it is going to provide you a lot of features, a lot of components, and every single component is going to create a little time additional to handle a single request. Well, Lumen is based on Laravel, and basically what Taylor Odwell, the creator of Lumen and Laravel, does was remove several components from Laravel for Lumen. In that way, Lumen only has access to the really strict and completely necessary components. And that makes Lumen really fast. As you can see here, it's even faster than Silex and Slim 3. And the good news here is that Lumen is ideal for everything that you need, of course, talking about microservices. In some way, you need additional features related with Laravel, so you probably need to use Laravel. But Lumen is ideal for microservices and service-oriented architectures because, well, you are going to focus only in the necessary structures, in the necessary components, and in the necessary features. Nothing else. You don't need a lot of capabilities and a lot of features to perform and to implement all the structures and microservices that we are going to use during this course, and probably for all the microservices that you will have in your service-oriented architecture. So let's talk a little about the architecture that we are going to use during this course. So here it is. We are going to have two possible microservices. The first one is going to be the books microservice, and the other one is going to be the authors microservice. As you can see, we have two databases for every single of them. So the book service will have, of course, a books database, and the author service will have an authors database. That means that every single microservice is going to be completely isolated, completely independent, and is going to have its own table structure for its own kind of resource. So as you can see here, both of them are completely isolated in its own cloud. Basically, you can run those microservices in your own server, in your own host, in your own domain, in different domains, in different ports, wherever that you need. Or, of course, you can do it inclusive, run both of them or all the microservices that you have in one single machine. Everything is going to be related with all your requirements. If you need to run every one of them independently, it is going to work. If you need to run them in the same machine, it is going to work anyway. So every one of them is completely independent, but there exists single requirements between them. For example, you need to be sure that an author exists before to create a book associated with it. And, well, the glue for this architecture is exactly this component, the API gateway. And the API gateway will have, of course, its own database related with the access or the security with OAuth 2, and optionally a users table where you can store which can access or which not. But mainly, the main purpose here is the OAuth 2 components or the OAuth 2 tables to validate the access from the external devices. So let's talk about the security. So you can see that, of course, the API gateway is completely isolated from the other services. And here is the difference. Here, those services are the internal services. In the other hand, you have the external systems or the external devices that can access directly the API gateway, but you need to control the access to this, and for that you can use OAuth 2. That is the reason because you have the OAuth 2 tables here, because, well, you need to be sure who can consume and who can't consume your API gateway, and that can be done using OAuth 2. That means that every single system or device that wants to access your API gateway needs to be completely authenticated using access tokens from OAuth 2. And there is a possibility there can be direct access, or any of those external devices can try to directly go and access your internal services, and that is perfectly possible. So it is your work to be completely sure that only the API gateway can access any one of those internal services, and that can be done easily using something called secret keys. Basically, the book service or the author service is going to validate the access through a secret key. So the API gateway knows the secret key and send it to the book service. The book service validates it, see that it is the correct secret key, and provide access. But if any external service like this or any other try to access directly the book service without using the API gateway, it is going to fail because, well, it is probable that doesn't know the secret key because it is a security measure. But again, the API gateway already knows the secret key and can get access to both the book service and, of course, the author service. So this is basically the architecture that you are going to implement. We are going to go class by class, step by step, to start implementing the author service, then the book service, finally the API gateway to centralize the interaction and the communication between those services, and especially implement the security layer to provide access only through the correctly authenticated systems using OAuth 2. And of course, finally, you are going to implement and block the direct access for the secret key because, well, everything is going to be centralized by security and facility through the API gateway. So once you understand the architecture that you are going to use and to implement, let's start in the following classes implementing the first microservice, which is the authors one. See you there.